Hey there, today we're going to be factoring by grouping, and the reason we're doing this is because we're going to figure out how to find the zeros of a polynomial without looking at the graph. Factoring polynomials is really fun. We're going to be learning some advanced factoring techniques. In fact, it's so fun that it deserves a meme. When the polynomial factors out perfectly, it's just, it's exciting. We have actually already done this before. Let me fix, this is actually the wrong quadratic. It should be y equals x squared plus 4x plus 3. That should be the quadratic we're working with. Anyway, the point is, we have already done this with quadratics. And remember, quadratics are a type of polynomial. If we were looking to find the zeros that aren't on the graph, or without looking at the graph, so typically we wouldn't have this graph here, we would just have the function. But we would know, hey, the 0 always has a y coordinate of 0 because it's right along the x-axis. So if I plug 0 into this function and solve it, I can find out what the zeros are. And we knew a couple of different ways of doing this. We could use the quadratic formula, we could use solving by square roots, though that wouldn't work here. But the quickest and easiest way, as long as you're good at it, was factoring. So if you remember, this factors into x plus 3 times x plus 1, because 3 times 1 is 3. Well, I'm not going to explain it that way. This foils back to this. So I factored it. At this point, we could make use of the zero product property. As long as this parenthesis equals 0, the entire product will equal 0. So if x plus 3 equals 0, I'm good to go. The equation is true. In that case, x equals negative 3. Likewise, if x plus 1 equals 0, my product will also be 0. So x would here equal negative 1 if I subtracted 1 from each side. So look, I found the zeros and I proved that that's where the graph crosses the axis. Now, we're going to move this sort of reasoning into the chapter about polynomials, except now, instead of factoring quadratics, we're going to have to factor cubics. And there are some very precise techniques we need to factor them. You're going to learn a couple, at least 3. Today we're talking about the factoring method that is called grouping, and there are a couple steps to grouping, so you really have to pay attention to what's going on here. The first step is I need to pull out a GCF, but I'm going to pull out a GCF only from the first 2 terms and only from the last 2 terms. I'm going to group them. So here's what I mean by that. I want to pull out the GCF of just these 2 terms. We're going to ignore the last 2 for now. So look at these 2 terms. What's the GCF? It looks like they have x squared in common. So I'm going to pull out an x squared, and that leaves me with x minus 3. All right? Great. Now we're going to do the same thing with these last 2 terms, and we're going to ignore the first 2 terms. So let's see, the GCF here I believe is 16, and let's actually pull out a negative 16, and you'll see why in just a second. If I pull out a negative 16, that leaves me with an x from the first term, and it would be negative 3 from the second term. Remember that when we pull out a GCF, whatever you pull out, if you were to distribute it back in, should get you back to the original problem. So negative 16 times x, that's negative 16x. Negative 16 times negative 3, that's positive 48. So it works. All right, now, something very interesting happened here. What do you notice? Look, now since we grouped, we have 2 terms. Here's the first one, here's the second one. Do these 2 terms have something in common? They do, and it's a little bit complicated, but look, both of the terms, this one and this one, have an x minus 3 in common. That means, second step, I'm going to pull out another GCF. So pull out another GCF, except this time the GCF is going to be complicated. The GCF is actually going to be this x minus 3. So I'm going to pull the x minus 3 out from this term, and this is going to look weird, but take a look at what's happening. When I pull the x minus 3 out of term 1, what's left over? Just x squared, right? If I pull the x minus 3, the thing in a box, what's left over? X squared. So the first term, if I distributed this back in, would be x squared times x minus 3, and that's exactly what's happening. Now let's do the same thing, but let's pull the GCF out of the second term. When I pull an x minus 3 out of the second term, what's left over? Well, it would be negative 16. So take a look at what's happening here. If I were to distribute this whole x minus 3 back in, x minus 3 times x squared gives me this. X minus 3 times negative 16 gives me this. And this is complicated and weird, but it should make sense. Next, we're almost done. Look, I factored it. I have something times something else. We just need to look for more factoring. And here's what I mean by that. More factoring. We need to see if any of these binomials can be factored further. So let's take a look at x minus 3. Can that be factored further? Well, no. It's already down to just a binomial. There's no power here, so I'm not multiplying anything to get this binomial, just x minus 3. But x squared minus 16, do you notice that this is a difference of squares? If you remember a difference of squares from last chapter, you could factor like this, x minus 4, x plus 4. And if you don't remember why that works out, take a look back in your notes, watch some previous videos. But let's think about how the FOIL works. I have x squared, great. This negative 4x and this positive 4x cancel. Good, I don't have an x term. And then negative 4 times positive 4 is the negative 16. Perfect. So now look, I've fully factored this cubic into 3 factoring terms. Notice what's going on here. When I factored the quadratic, I had 2 factoring terms. Now that I've factored the cubic, I have 3 terms, and we can apply the zero product property to find the zeros. So plug in 0 for y. That would mean if this parenthesis equals 0, I'm good. So x could equal 3. If this parenthesis equals 0, I'm good. So x could equal 4. And if this parenthesis equals 0, I'm good. So x would equal negative 4. So my 3 zeros are 3, 4, and negative 4. And check this out. Look at the graph. Oh, I'll go back to that. Look at the graph. Negative 4, 3, 4. Marvelous. Those were the zeros that I thought they should be. That's what I solved for on this last slide. By the way, this is a perfect time for this guy. He's pretty much my favorite mean. Yeah, factoring inside of factoring. That's what this guy is good at. All right, so let's do another example. Remember, what I solved for was the zeros, and if you actually look at the graph of this function, yes, those are actually the zeros. I just found them. Really, really cool. Let's do another example. Okay, we're factoring by grouping. Let's see if we can remember the steps. First, we're going to look at these first 2 terms. Ignore the second 2. We're just going to pull the GCF out of the first 2 terms. So that, in this case, is x squared, and I'm left with x plus 7. Great. Now let's do the same thing to the second 2 terms. The GCF here is clearly negative 9. That leaves me with x plus 7. And again, you can check your work. If you distribute back in, that really does get me back to here. All right, now what did I notice? This term has an x plus 7. This term has an x plus 7. So if I pull x plus 7 out of both terms, I'm left with, it's gone from this term, it's gone from this term, I'm left with x squared minus 9. Now, clearly, the x plus 7 cannot be factored any further. But what do you notice about this? Oh, hey, it's another difference of squares. So I can continue to factor it. You're going to be seeing a lot of difference of squares in this section. It just happens a lot because it enables us to factor further. And it's textbook problems, so they work out perfectly. So x plus 7 couldn't factor further, but this x squared minus 9 can factor further. It factors into x minus 3 times x plus 3. So let's take a look at the zeros. Use zero product property From the first parenthesis, x would equal -7, like if I subtracted 7 from both sides. From the second parenthesis, x would equal +3, like if I added 3 to both sides. And from the final parenthesis, x would equal -3. So these are my zeros. This should be where this graph crosses the x-axis at -7, 3, and -3. Let's double check that. Okay, we have -7, we have 3, we have -3. Wizard! We did it! Yay! So factoring by grouping, it only works in these very specific textbook type problems where things work out perfectly, but it's always exciting when it does. Summary: to factor by grouping, first you're factoring out a GCF from the first two terms and the last two terms. You group them separately. Then you should have this common term, something like in the last example it was x plus 7, that is in both of these new terms you've created, and you can actually factor that out. Finally, you're going to look for further factoring. Typically in this chapter, when you factor by grouping, you will see a difference of 2 squares. Not always, but you'll see it come up often. Hey guys, that was a complicated video. Don't come into class and say you didn't understand anything. Rewatch the video. That's the whole point of it. You can get it. There are very specific steps. Just rewatch it. Do a little bit more thinking, and we'll do some examples in class. Thanks for watching. Ciao.